Hi, Mikhail Hirschfeld here to talk about my exploratory data analysis and literature review for my project, which is seeking to predict accident severity based on traffic data. I'm very interested in all things mobility analysis and vehicle safety, which is why I'm doing my capstone on this topic. Just a quick recap on my topic idea in case you may not have seen it. So the data I'm using comes from 3 million accident records taken in the US from 2016 to 2019, and my goal is to be able to predict accident severity in terms of the traffic delays they cause based on only on immediately known variables at the first reporting of the collision. And this is based on a hypothetical use case of a GPS software being able to immediately warn motorists on the road of a long delay in traffic somewhere. And I want to be able to get a sense of some of the most explanatory factors for these severe accidents, and if any anomalies or outliers are seen, I can look into these. So one study I found, I use a conglomeration of different data sources to be able to predict severity, and severity here was a discrete label based on vehicle damage and injury rather than traffic delays. The method they chose produced very high accuracy metrics, and even more so when features were carefully selected. And I found this one to be focused more on the methodological rigor rather than qualitative insights on some of the more explanatory factors. And another study that was done a few years back used very similar data for a very similar purpose, except it did a deeper dive into these explanatory variables. Some interesting factors that were associated with more severe accidents were if it happened in a rural area, if it was a single vehicle collision, a rollover collision, and if there was poor lighting at the site of the crash. So although this wasn't explicitly in my data, I do want to touch on autonomous vehicle collisions as well, with most everyone predicting that autonomous vehicles are the way of the future, and at some point every car on the road will be autonomous. There is some limited research here. Last year, a study was done on 114 different collisions in California from 2014 on. California is actually requiring all autonomous vehicle collisions to be recorded, so that's where this came from. So some general findings from that were autonomous mode generally led to more severe collisions that were usually the fault of the AV system, while minor collisions from both conventional and autonomous mode were usually very likely to be the driver's fault. So it's very difficult to take any conclusions from this because the data is so limited, but this serves as a good starting point for this field of study. So some takeaways here. My goal is fundamentally kind of different than what these studies are trying to accomplish. I'm defining severity differently and basically just trying to predict delay from only a certain subset of features. However, there are still some insights from the methodological approaches that they use when they talked about the models. Ordinal logistic regression and tree models were shown to be very effective. In particular, the first study, John Feng, it gave some very good insights into the factor analysis that I'm looking to conduct. And of course, understanding how AV crash patterns work is the first step into the evolution of this field of study. So onto my exploratory data analysis. So at first glance, my data, I also did have some data on bad driving metrics quantified by state. Overall, I chose not to incorporate this. It seemed very unrelated to a lot of the data I had, and they were more aggregate terms, and there was no good logical merge. So I just chose not to incorporate that because there's plenty of data I had available to me. So much, in fact, I only sampled a little less than half of it just due to my computing resources available to me. So there were a lot of missing values as well for some important features I was trying to look at, namely weather. So I had to fill in the missing features as best as I could and interpolate the rest. So some trends here. The distribution of the severities is very bimodal. Almost all of these are a 2 to a 3 severity. And whether it occurred on a highway or not seemed to be the most influential factor on the severity here. So here's a parallelogram of how the different continuous features relate to each other. Notice none have a real large impact on severity. An interesting find here. I think the graph might be a little bit cut off, so I'll just explain it. So I found that West Virginia and Arkansas actually had the highest percentage. They had very high percentages of severe collisions, and they had actually a large enough sample size that these results were valid. I think the mean was about 3.3% of collisions were the most severe. And West Virginia and Arkansas were both around 20, which was statistically significant. So this is the exact kind of outlier that I'm looking to investigate. My references, and thank you very much.